Hello, in today's video we're going to be discussing part 1 of section 5.2 on solving special systems of linear equations. Our essential question for this topic is, can a system of linear equations have no solution or infinitely many solutions, and what do these solutions mean? So I'm going to ask you to take a moment and refresh your memory on solving systems of equations by graphing by pausing the video and completing this example now. So to solve by graphing, this is already in y equals mx plus b form. So b then is equal to 1, and my slope m is negative 2/3. So if b is 1, I start here at 1. Negative 2/3 means I go down 2 and right 3. Or I can make the 3 negative and go up 2 and left 3. So my line is going to look something like this. My next one I will do in blue. My y-intercept b is a negative 3, and my slope m is negative 2. As a fraction, that would be negative 2 over 1. Or we can move that negative down to the denominator. So b is negative 3. My slope is 2 over negative 1, or negative 2 over 1. So down 2, right 1. Or I can go up 2, left 1, up 2, left 1. Up 2, left 1, up 2, left 1, and draw my line. Now there is one point of intersection. The two lines cross here in one place, which means that the system of equations has one solution. And that solution specifically is an x value of negative 3 and a y value of positive 3. So if I go back and I plug in negative 3 and positive 3, it will work for both of these equations. Or if I plug in an x value of negative 3, I will get a y value of positive 3 for both equations. So now we're going to see what happens in these two. So equation 1, just as before, I will do in red, and then equation 2 I will do in blue. So here my y-intercept b is 1, and my slope m is 2, or 2 over 1. So I go to my y-intercept of 1, and then up 2, right 1, up 2, right 1. And then I can also change the sign on both of these and go down to left 1. So down to left 1, down to left 1, and we can see that these points are all still in a line. Connecting these dots, my line looks something like this. And then I move on to my second equation, which I will do in blue. I've got a b value of negative 5 and a slope again of 2, or 2 over 1. Which is the same as negative 2 divided by negative 1. So a b value of negative 5 would be here, and then a slope of 2 over 1 means up 2, right 1, and down to left 1. And connecting these dots, my line looks something like this. Now I notice something interesting about this system of equations, and that is that the lines are parallel. Parallel lines is something that we've discussed before, are lines that have the same slope but a different y-intercept. So the slope of my blue line is 2, the slope of my red line is 2, but notice they're in a different place. So they're parallel, they're never ever going to cross. So there is no point of intersection. If there's no point of intersection, the point of intersection tells us where our answer is. If we go back to our first slide, the point where they cross is where our solution is. Well, if there's no point of intersection, that means there's no solution. So this system of equations has no solution. There is no pair that works for both equations. They have nothing in common. All right, your turn. Pause the video and try out these two on your own. My first equation, I've got a b value of negative 2 and an m value of negative 1, or negative 1 over 1, which would be the same as 1 over negative 1. So b value of negative 2, and then down 1, right 1, down 1, right 1, down 1, right 1, or up left, up left, up left, up left, up left, giving me a line that looks like this. And then for my second equation, in blue, I've got a b value of 4, a y-intercept of 4, and an m of negative 1 again. So notice they have that same slope. So chances are these are going to be parallel. They will be parallel if they have the same slope and a different y-intercept. So I can see already they have the same slope and the b values are different, so already I know they're going to be parallel. But let's go ahead and graph it out. My b value is 4, my slope is -1/1, or up 1, left 1, and drawing my two lines, I see that they are in fact parallel, meaning that there is no solution. There is nothing that these have in common, so there is no ordered pair that works for both. Lastly, I've got a b value of -4 and an m of -5/3, or I can change the sign on both, +5 over -3, so -4, and then down 5, right 3 takes me off my graph, so I'll go up 5 and left 3, and connect these dots to draw the line that represents this equation. And my second equation has a y-intercept of -2 and a slope of -5/3. So I see that these have the same slope. So if their y-intercepts are different, then they are parallel. Notice that these are different, so I can expect my lines to be parallel. I'll go ahead and finish this all the way out, just so we can see them in the graph. So a b value of -2, and then down 5, right 3 takes me off my graph, so I will go up 5 and left 3, and connect my dots to form a line. And sure enough, these lines are parallel as we expected, so therefore there is no solution. These equations have no point in common. We can also have a system of equations that has no solution by solving with substitution. So we could solve these by graphing, but we're going to practice solving by substitution and seeing what happens. I'm going to tell you that both of these have no solution. So let's see what happens when we solve by substitution. Substitution means that I know what one of the variables equals, so I'm going to take that value and plug it in for the value in the other equation. So I've got -12 times x minus 3 times y is equal to 7, but we know that y is actually -4x plus 3. So now I can solve. I'll distribute. -12x plus 12x plus 3 is equal to 7. We are looking for the x value that makes this statement true. -12x plus 12x is 0 x's plus 3 equals 7. My goal is to find the x value that makes this statement true. 0 x's, that's just 0, plus 3 is equal to 7, which means that 3 is equal to 7. So what I'm looking for is the value of x that makes this statement true. Well, there's no x in this statement, which means that there is no value of x that will ever make this statement true. So that tells me that this system of equations has no solution. All of our x's are gone, and we have a false statement. 3 does not equal 7. That makes no sense. So our system of equations has no solution, meaning that our lines are parallel. Number 2, I'm going to have you go ahead and pause the video and try solving this one using substitution on your own. I know what y equals, 6x plus 6, so I'm going to substitute that in for y in my other equation. 18x minus 3 times y is equal to -3, but I know what y equals, that's 6x plus 6. So now this is something I can solve. 18x minus 3 times 6x is 18x. -3 times +6 is a -18, and that's equal to -3. When I subtract 18x and 18x, these are inverses, meaning they cancel each other out. 18x minus 18x leaves me with no x's at all, so -18 is equal to -3. Now our goal is to find the value of x that makes this statement true, but all of our x's were eliminated. Or in other words, our x's are gone, and we have a false statement. There is no way that negative 18 could ever be equal to negative 3. So this system of equations has no solution. If there's no solution, that means that our lines are parallel. Lastly, we're going to explore what happens when we solve the system by elimination. So I'm going to have you go ahead and pause the video and try solving by elimination first, and then I will walk you through both of these. To solve by elimination, we want to make sure that we have additive inverses. So I'm going to multiply the top by a negative 2 so that I have a positive 4x and then a negative 4x in the equation below. So that means I need to multiply everything in this first equation by negative 2. So that first equation becomes positive 4x plus 4y is equal to negative 6. So then when I add those two equations together, negative 4x and positive 4x, I've got 0 x's. Negative 4y plus 4y gives me 0 y's is equal to 12 minus 6 is 6. 0 times x is 0, 0 times y is 0 is equal to 6, so 0 is equal to 6. So we are looking for the value of the variable that makes this statement true, but all of our variables were eliminated. And we have a false statement. 0 does not equal 6. Those are two different numbers. Therefore, the system of equations has no solution. If there's no solution, that means that our lines are parallel. If you haven't already paused and tried the second one on your own, go ahead and do that now. In order to eliminate, I'm going to go ahead and multiply this top equation by a positive 2. Positive 2 allows this x term to be a positive 10, which will eliminate with my negative 10 below. So I multiply everything in that top equation by a positive 2. So this top equation then becomes positive 10x plus 4y is equal to negative 14. And then I add negative 10 and positive 10x give me 0x, negative 4x and negative 4y and positive 4y give me positive plus 0y equals, and then 4 plus a negative 14 gives me negative 10. 0 times x is 0, 0 times y is 0, and when I add, 0 equals negative 10. So we are looking for the value of the variable that makes the statement true, but all of our variables were eliminated. So there is no x value or y value that will ever make that statement true, and 0 does not equal negative 10. This is a false statement. It makes no sense. Therefore, our system of equations has no solution, meaning that our lines are parallel. That brings us to the end of our section for today. We'll go ahead and pick up in part 2 in a later video. Thanks so much for watching.